So here's a great real world question. We'll actually see where this comes from later on in the course. First things to do, we need to substitute the value of the polynomials into the original equation. This should be pretty obvious for you guys. So we get 80 equals n over 2, we don't know what n is yet, times 2a, 2 times 4 is 8, plus n minus 1 times 6. First things first, we're actually going to rearrange this so it's round the other way. The other thing that we're going to do is we're going to multiply both sides by 2 because this fraction is just a bit annoying. So after we do that, we end up with n, 8 plus, I'll just reverse this brackets into 6n minus 1. That should be easy enough for you guys, equals 160. Now this is looking a bit better, we can start expanding. So we get n brackets 8 plus 6n minus 6 equals 160, or in other words, n brackets 6n plus 2 equals 160. Then we can expand again, so we're left with 6n squared plus 2n equals 160. Now this is obviously a quadratic, so we want to move everything over to the left hand side. So we've got 6n squared plus 2n minus 160 equals 0. You might notice that we've got a common factor everywhere here. We divide both sides of the equation by 2, and of course 0 divided by 2 is going to stay 0. We now have 3n squared plus n minus 80 equals 0. Okay, no common factors here. We can either try and put it in the quadratic equation, or we can try and factor it. I would prefer that we try to factor it, and we'll see what happens when we do that. I might just split up page in 2 and move our equation back up here. So we've got 3n squared plus n minus 80. Now if we borrow the 3, we're left with 240. And we want to find two numbers that multiply to give 240 and add to give 1. Well, really, two numbers that multiply to give minus 240 and add to give 1. So we want to find two numbers that have a difference of 1 and multiply to give 240. Now, this one might take a little thinking. We might try, though, 15 and 16. Because if we put into our calculators 15 times 16, we should get 240. So, we're left with the two numbers. We're going to have a positive 16 and a minus 15. There we go. Unborrow the 3, so that's 3 and 1. We have to take the 1 away from the 16 to give 16. 3 from the minus 15 gives us minus 5. And that means we're now left with 1x, so x minus 5, and 3x plus 16 equals 0. Which means that if we're looking for the positive value of n, you might notice automatically that you can't make this equal to 0 if x is positive. Okay, should be using n here. Might just quickly change that so we don't get confused. So this can't be positive. Only the n minus 5 can be positive and give 0. So therefore, n has to equal to 5. Okay, otherwise we'd have n equal to minus 16 on the 3 if we just solve that, and that's not positive. Now, if you want, we can substitute it back in, but I'll leave that one as an exercise.